So for here, look.
Future.set gets more.
All right, everyone. Let's start on the live review for this. How did this go?
It went a little bit.
It went a little bit. Does anyone have the game of life working? It's like ticking. Someone probably needs to mute. Maybe that's me. Is that me? Okay. Yeah. Does anyone have a glider gliding? No? Aww.
Close.
Yeah, we need like another half hour on this workshop, I think. Noted. Okay, well let's start the live review and get through what we can. I think we'll get a glider gliding, hopefully. So I've just brought up the specs and the code here, and I'm just going to start kind of burning through it with a little bit of time to like describe what's going on. So the first thing the specs want us to do is write the set method. We have our board class here, which is basically a wrapper around a flat uint8 array that lets us index it by row and column. So that's all the board is really doing, is giving us sort of a two-dimensional view of a one-dimensional array. And we already have this method that handles the math for that. So it says, given a row and column, specifically given a array that contains a row and column, so a coordinates object, we're going to use this expression, which is row times width plus column, to figure out the index for that cell. And you can sort of reason about why that should work, right? It's like you basically multiply all the width of the board by all of the rows that you're stepping over, and then you add the column. And this is called row major indexing. We could flip the sense of this and do column times height plus row and get column major indexing, which are just two different ways of serializing the two-dimensional grid into a one-dimensional array. Basically, do we go left to right, or do we go top to bottom? All right, so get is written, set is not written. Set is pretty similar to get. We'll just say that this dot cells of this dot cells of this dot index for chords equals value. Okay, and this is mostly teaching us to use the index for function. Living neighbors, who wrote a loop for this? Okay, who did not write a loop for this? So we're going to try and loop over all of the neighbors of a given coordinate. We can, looking at index 4, notice that this, let's see, this returns undefined if we give it an invalid index. This will return 0 if cells is dereferenced with an invalid index. So it looks like if we want to consider cells that are off the board as dead, we don't have to do anything special. So we don't have to ask, like, am I at row 0 and worry about indexing into row 1. So that means that I can kind of just write relatively dumb code where I do like this dot get, and what'll it be? Row -1, column -1, plus 2, 3, 4, 5, 6, 7, 8. Okay, so row column, row -1, column +1. You might be thinking, why isn't she writing a for loop here? I actually think this is like perfectly clear is the thing. Whereas a for loop we could sort of loop over like from -1 to 1, and then from delta y is -1 to 1, sum this get. But it seems just as easy to duplicate these 8 lines of code. We're saving like 3 lines of code to make the conceptual code more complex. So these can go Column -1, column +1, and then this should be +1, and this will be just column, and this will be +1. Oops. Great, so that passed. Did you see the problem here? It returned on line 67, and then this is just dead code. Oops. I can't put in line breaks everywhere I want to. Okay, questions about that? All right, moving along. We're gonna get to tick really soon, where I know most of the pain is. So toggling is super easy, I think. We should just say this dot set, set at chords, this dot get at chords. What can I do here? It would be like not. Will that work? Yeah, that works. And this works because of a trick, basically. This works because when we get 1, if we... So let's just look at this in the console. Oh no. So when we call get on the board, we're gonna get a number back, so it'll be like 1 if the cell is alive. Not 1 is false, and if we set a small board, oops, and if we set okay, so now I have this int array. If we set some index of an array to false, it'll set it to 0. That's specifically for these numeric typed arrays, because they can't hold the actual value false. JavaScript gives you the next best thing. Okay. Next, the Conway function. Okay, this is the second hardest function to write, I think. So what are the rules? Okay, living cells with less than 2 neighbors die by underpopulation. So if we're alive and num living neighbors is less than 2, then we'll return false, otherwise true. That's not all of the rules, though. So with more than 3 neighbors, die of suffocation. So actually, let's flip the sense of this. Sorry. And say that spam calls. Great. Okay. Here, let's write this out kind of less tersely, and then we'll tersify it. So if we're alive, if num living neighbors is less than 2, return false. Let's see. If living cells with 2 or 3 neighbors survive. So if num living neighbors is greater than 3, return false. Dead cells stay dead if they have living neighbors isn't 3. So if so, otherwise, return num living neighbors isn't 3. No, wait, sorry, they stay dead. Great. Oh, so this is return true. Okay, cool. I think we can actually even simplify this code a little bit, because if we flip the sense of it and just ask, what makes a cell be alive? So a cell is alive if, in the next tick, if it's alive now and its living neighbors are greater than 2, wait, it's less, greater than or equal to 2 and less than or equal to 3. Otherwise, num living neighbors is 3. I have this sense that there's an even simpler version, like...
We kind of came up with kind of a simpler solution. We looked at it and just saw to see if it's alive.
Yeah.
If it was alive, we went through the cases of what it is, and then depending on what it is, like let's say if neighbors is less than 2, we just said that is alive is false, and then kept going, and then at the end we just returned is alive, which at that point would be
set to something. Yeah. I kind of find it, when writing things like this, I sort of like to, I basically like to not reassign variables if I can, because it can make it harder to reason about if you add more checks, if you add more complexity. So if you can sort of express the flow of data or the flow of checks as like a straight through mathematical thing, it can make it easier to change, because like you don't have to think about like, oh, what if like is alive has changed already at some point in the middle of the function. Okay, we'll go with this. Maybe the fellows can pipe up and tell me if there's like a more elegant solution in the solution.
It was a little confusing just why it was talking about recursion when it didn't really seem like recursion. Oh
yeah, so it's, yeah, so right, this is not a recursive function, but it's like a little recursive-ish. It like suggests recursion in the sense that it takes a value that it also returns. So it's taking whether something is live and it returns whether it's alive, which means that if something is driving it, and in fact we're about to write the thing that's going to drive it, it's kind of using this mathematically, if not like strictly speaking, like programmatically recursive. It's using this like mathematically recursive process to like generate information somehow. And this is that's mentioned in the workshop because this is a general, sort of the general case of this is a specific case of a more general pattern called a reducer, named after the like array reduce method, or really the array reduce method is named after this technique, where you write this like sort of like half of a recursive function, and in doing so you are describing the behavior of a system that evolves over time. And we'll see that later when we learn Redux. Okay, I'm going to go with this and say that that's terse enough. I hope it is. Okay, last one, the tick function. What should I do? What are my options here?
Try and find out the coordinates of, we have an index.
Yeah.
Try and find out what the coordinates were so we can find how many number of living cells it has to put into the rules function, because we need to put if it's alive, which we know because it's 1 or 0.
Yep.
And then we need to find the coordinates to get its number of things.
Yeah. So one option is exactly that I can have an index. So I'll say the index is present.length, and then as this index goes to 0, then that is like arguably more confusing than it needs to be. But it does look kind of cool, right? This is my editor turning this into what looks like an arrow. And it actually does kind of look right? As index goes to 0, And that's exactly what's happening, but it's sort of a lie, because what's actually happening in JavaScript is that we're saying decrement index and simultaneously check to see if it is greater than or equal to 0. This is the fastest way to like loop through a bunch of numbers in JS. The other ways are not much slower, so don't get hung up on it. Don't like desperately try and use this where it doesn't fit. My computer is telling me a new version of Java is available, which tells me that Java is installed, which is really upsetting. Okay, so for each index in the present, I could basically reverse this function, this index4 function, and get a coordinate out, and then call living neighbors on that coordinate, and everything will work out. Is there another option? So let's sort of write that pseudocode. Future.set chord to be rules of. Okay, so this, I could do something like this. Basically, I could do this, but I have to write this coord4 function. Is there any way I can avoid writing the coordinate4 function? Yeah.
We directly took cells from the board itself, because the board it has cells, and we just put index on that particular cell.
Yeah, exactly. So you can, let's see, but then how do you get the living neighbor? You mean the coordinates of the individual cell?
Because it's internally an array only, so we have all the cells. So we look through the board.net. So and then we took each cell and we just apply that rule on that each cell of that index. Suppose I.
How do you get the count of living neighbors for a cell that way?
Because we are passing that rule as a conjugate, right? So we apply rule on each cell.
Right, but how do you get the coordinate of that cell? So one thing to observe is that we actually know all the coordinates on the board, right? We know the number of rows, we know the number of columns, and the coordinates aren't really, there are like no surprises in there. They go from 0 to 1 minus the number of, or to the number of rows minus 1, and 0 to the number of columns minus 1. And so we can just write some loops, right? We can say, here, I'll write these as for loops. So, well, row is in all of our rows. So for row equals 0 to present dot, is it rows? Height. Present dot height. And then for each column, now we have a coordinate, right? And we can do this stuff.
And then we could do it on like
Boom. Yeah. So both of these are good approaches. If we wanted to write coord4, we could. Let's try doing it. So this function will take an index and return, so let's see, the signature is, I should probably call chords4. index will be an integer, and this will return row int call int. And we'll say, given an index, return the row call that maps to it. And so we basically need to invert this mathematical expression. So first let's make sure that our index is valid. So if index is less than 0 or index is greater than this dot board, is it board? This dot cells dot length, less than, greater than or equal to, then we'll just return. So that's the equivalent of this check. We're checking for out of bounds. And otherwise, we'll return, okay, we can do this. It'll be the index divided by the, oh wait, the row will be the index divided by the height, no, width, this dot width.
Higher. The row is like,
Yeah, how many rows are in the grid?
Really?
We had it the other way and it didn't work.
Wait,
Yeah, I was confused. Like the rows
but we're
are-
multiplying by width here. Shouldn't we divide by width?
Oh, yeah.
I,
Oh, wait. No, by height. Because rows are 1, 2.
I'll type height. Well, I'll type height. Let's,
Right.
okay, I don't,
No,
if it is height, then I think these specs aren't complete enough, because I think it's not. Or if height works, I think we aren't having a case where it wouldn't somehow, but let's find out. So we also want the floor of that, right? So we want to basically ignore the rest. And then the column will be index mod this dot height, presumably, again.
well, we only ever create mods on this that have the same
Uh,
They're always squares.
okay, so let's just, that's right. Okay, so our spec is a problem. It should be width, though. Should I prove it?
No,
Because we're multiplying by width here. We're trying to invert this mathematical
I
operation.
understand what you're saying.
So we should divide by width,
Yeah.
yeah.
Same numbers.
It is a little counterintuitive, right? Because the row is, it's like the number of rows is the height of the board, but the row index, each row is the width, is like width number of things. And so to figure out which row we're in, we divide by width. Okay.
It doesn't make sense.
And just for fun, I'll take width out of this. I like doing this sometimes whenever I index into whenever I use a property a lot. It's like slightly faster, it's slightly terser. Okay, let's flip over to this approach and see if that works. Oh, wow. Chords 4. No, still no. Am I returning this? I am. Is my,
But this don't work.
I did this weird thing. Let's just log some stuff. This is not getting called at all, which is very suspicious.
Aren't they supposed to get returned like as both of them together?
I have a question here. In that function, why we can't directly use our cells? Why we need coordinates? Why we cannot use a cell with index? Because we are just applying that rule on each cell, right?
So the rule takes the living neighbors, and the living neighbors is defined in terms of the grid. And so we need to know the coordinate on the
But
grid.
that rule,
Present.cell will
Present dot cells where? Oh, thank you. Why is that not? Oh, because index. Right. Okay. This would fail silently, wouldn't it? Because it starts as undefined, while undefined is equal to 0, which it never is. So we never get into the for loop. Thanks. That's that's the answer. And I just crashed my program. No, I didn't. No. Yes, I did. Now I printed a bunch of stuff. Hopefully. Okay, let's not print that. Let's try again. Cannot iterate over undefined. That's very surprising. On line 85. Let's see. Oh, I'm calling living neighbors on something invalid, I guess. Why? Because I'm returning an invalid coordinate. Okay, why is that?
Well, should the index start at the length or start at length -1?
So it should start at length -1, but it does because this for loop construction decrements it before anything else happens, which I know is strange, but that's what's going on.
I think it's a similar on line 136. It's similar to line 135 where you want to look for the present.cells coordinates.
No, because this present is the board, and we do actually want the coordinates for this index.
It wouldn't implement it after index goes through the first time. It would. You have to put it before it, right? So it would implement it initially and then go into the while loop. It'll implement index. Decrement index and then go into it.
Yeah, this loop construction is correct.
Okay.
Yeah, so it decrements it and then goes into the loop. Why does it do the decrement before?
Yeah, I thought like when we put it after like that was the for loop. And we said I plus plus, it would take I and then go into the for loop and then go back and
So right, so this decrements the index, returning the current index. But by the time we get here, the index has already been decremented because it got decremented here. Present cells line. Okay, but I do see something's up because why am I seeing like 500 in here? Okay, here. Maybe there's something. Let's try rewriting it. So oh, there. So I did do something wrong. What was it? Present cells .9. Oh, maybe. Yeah, sorry. You're right. You're right that this has to come first. Yeah. Yeah.
Well, the way I read it was when it comes after the variable name, it's going to take the variable name first. Whatever is stored here initially, it's going to take that first and then go through it and then come back and do it after it's taken the initial. Since the variable comes first, it's going to take that first and go into the loop and then come back and decrement it or increment it.
So not quite, because it only matters for this expression, but that expression is important. That's why we weren't stopping soon enough. So here, let's look at a little example. So if I have index equals 10, so let's say I have something with 10 things in it, and I start index at 10. If I say like if minus minus index is greater than or equal to 0, and I log index, what's this going to be? 9. Okay. Let's reset index. What if I do if index minus minus is greater than or equal to 0?
10.
No, still 9.
Why?
Because where the minus minus goes only matters in terms of the value of this expression. So index minus minus has the value of that index currently has before the decrement happens. In fact, we can just see this. So index equals 10, index minus minus is 10. Minus minus index is 9. In both cases, index is 9 afterwards. It's subtle, but it means that at the very end, during the last check, if I said index minus minus, then when index is 0, we decrement index to -1, and the value of this expression is 0. So we can look at that. When index is 0, then index minus minus will be 0, but then index will be -1, which means the chords will be undefined, which means we would get that error that we were getting. So it has to be minus minus index to make this construction work. So I was wrong when I said the construction was correct. Okay, either of these approaches to writing tick is fine. I think this nested loop one is slightly preferable because you don't have to do this math every time around the loop, but it's really an inconsequential decision. So
Could you have put the whole, instead of doing the let index line, just done it all inside of the for loop?
Yeah, this could also be a for loop.
Okay.
This could also be for let index equals 0, index isn't present. Yeah. These are basically equivalent. This loop construct is faster slightly. This one is arguably more standard. I don't know, you do see this a lot actually. Like if you go look at the underscore or like the not downline, underscore code. What is that library that everyone uses? Lodash, there we go. If you look at the Lodash code, it's just full of this. With nested loops. And we could also use that construct here, right? We could do, so let row equals present dot height while minus minus row call equals present dot width. Oops, you don't need to do it twice. The only difference is this goes through it backwards. So sometimes you don't want that. Okay. Any other questions? 27 years.
Seriously?
Yeah. So don't feel bad if it seems like this is happening very fast. In 27 years, I'm sure it will be happening very fast for you too.
Like, how old are you? 2?
A little older than 2. Not much. Okay. Shall we look at our actual game?
Were we, like, in this allocated time supposed to get to the end of board.js or the end of game.js?
You're never, like, supposed to finish the workshop in the sense that, like, it's not an expectation that you finish the workshop. I think people usually don't finish this workshop. People usually do get to some of game.js, but people also usually have, like, another half hour than we had because of scheduling's always a little weird. But feel free to keep hacking on game.js. After you've gotten this far, you're very close to having a working game, so it'll be very satisfying to finish. I think you're very close to having a working game. Maybe? Maybe? Okay. Yay. Okay, and now let's get our game working. So what do we have to do in here? Okay, paint. Oh, right. So paint is this function where we have a couple of options. We can either query the DOM and find all of the cells, or we can collect them when we create them. Let's do that. That one sounds great. So let's just remember some cells. Do I have like a cells anywhere? No. How about we'll call this TDs? No, let's call it table cells. I'll be verbose today. And after every time we append a TD, we're just going to say table cells.push that. So now we've, oh, wait, let's go look at our thing. Where am I? GH1801. Okay. Nothing's happening. Is anything crashing? Table cells is not defined. Oh, ha ha ha. We should define it before we call it, right? That would be nice. Store the table cells we're about to create. Yeah, it's just all in the life function. Okay, so we're not crashing anymore, and if we look at, if we like log table cells, maybe we'll say like window.tc equals table cells. This is a trick I use a lot just to throw stuff on the window when I want to access it here. So here are all my table cells, great. And then you probably want to delete that so you're not just like cluttering the Windows namespace with stuff. Okay, so now that makes our paint function relatively easier, right? We can just be like, who wants me to use that stupid while loop? Who wants me to use a for loop, like God intended? Okay. So for, oh, actually, wait, no, there's another kind of loop. Is there another kind of loop I can show you? Do I have the index of this? I have the coordinate of this, which is good enough. Okay, I'm going to show you another kind of loop, sorry. Today is just a day for loops. Do you know for of loops? For of. These are very, these are like kind of new and like are just being released into the JS mainstream. But in particular, they're just being optimized, so they might not be the fastest, but they look very nice. So I can say for let td of, what did I call it? Table cells. So of here, you can, this can be a var as well, but if we're using ES6, let's use ES6. So this says iterate over table cells and each table cell, call it TD. It's kind of the most natural looping construct, the most natural to read looping construct. And if we look at it, td.coord has the coordinate that we need. We also have a board, the present, and so I should be able to say td.classlist.add. Oh, I guess I need to do the check first. So I can say if present.get td.chord, chord, right? Yeah, singular. Add alive, otherwise remove alive. Oh, so that's working. Wait, that works, right? The fact that I click this and something's changing means it's working.
Yeah.
Okay, so that's pretty exciting. Next, we can remove that console log is what I was trying to do. Oh, I guess I already did. Finally, let's make it so that we can paint things on the screen, or that is so I can draw on this board by fixing this event listener. So how do where is this event listener? Help me, toggle cell from event. When I named that function, I was in a very like Swifty place, wasn't I? All of Apple's function names kind of sound like this, like application delegate will close from event, blah, blah, blah. Okay, so right now we're just getting element 0, 0. Instead, I think we want to use event.target. And is that just all we need to do? Yes, that's all we needed to do. Okay, cool. So now I can play, right? No, I can't play. Can I step? What's that?
Sorry, where did you get target from without getting it slowed down?
Oh, I got it from this hint, which is that events carry the target. They carry this property target, which is the actual DOM node that the event actually occurred on.
We've written that on events or
I think it's a part of it, like the process, that thing we were supposed to do.
Yeah, it's part of the event specification, so all DOM events have it.
Oh, I see.
That's why they pass it in. The event.
Yeah, that's why they pass the event in. I mean, there's a lot of other things you can get off the event, like the exact position it was clicked, what pointing device it was clicked with, what pressure the stylus was pressed with, if it's a stylus being pressed onto a touch screen. There's all that stuff that, like, let's just log this event.
It just comes in like an object.
Yeah. So if we just look at what happens, let's reload. So here's the event object we're getting. I just put a console log in here to log it, and
to do the pixels, like the coordinates of the pixels.
you don't have to for this, but we're just taking a little tour and seeing here's all the crap that's in this.
Yeah.
Like source capabilities. Do I fire touch events? No. This is useful sometimes because you want to say like, oh, if you can use touch, do something else. Otherwise, you're on a desktop, and so do that thing. Here's the view that I'm attached to. I've never even seen this. I don't know what that is. I don't know what a lot of these things are. Here's the path all the way up from the window down to the thing that triggered the event. And then a whole bunch of different ways of telling you what pixel this event occurred on. Like, depending on whether you want it relative to the page or the node that it occurred on or the screen itself. Yeah, there's a lot. It's how all those like crazy browser demos work.
Yeah.
Okay, so now we should at a minimum be able to make a glider walk across the screen. I think that's one generation of a glider. So if I click step, it should go to the next generation. There we go.
So step invokes that one we wrote tick.
Yeah, I'm going to delete this very, very, very long comment. Sometimes I write too much. Okay, there we go. Yeah, so step just calls tick and then calls paint. Okay, that's great, but it would be really nice if I could just click play. So let's make play work. Let's start playing by running the step function automatically on a fixed time interval. So I guess I'll use set interval. And I don't remember if it's, I can never remember if it's timeout and then the function, or the function is the function and then the timeout. Okay, so we'll say every 100 milliseconds call step. And we also want to be able to stop it, so let's capture that interval. Playing equals null. Set interval. Okay, so now when I hit play, probably nothing happens because I didn't wire up that button. So let's wire up that button. This should be play, and this should be, wait, pause. Oh, I see. Play should actually call toggle playing, which either calls play or stop. Right. So if playing, stop, else play. Toggle playing. And then I guess the last thing is to connect the reset random button, which I'll do, oh, and clear. So let's do clear first. And while I'm here, let's connect the random. Is it rand? What is this? It's just random? No, it's a reset button. But the function is called random. Yeah, okay. So we'll wire that one up. Reset button to be random. Okay, so now when I click play, I should, oh no, break everything. What did I do? Unexpected token else. Oh, that's right. You can't put it all in one line. Unless you do this, maybe this'll work. You could also just do this. Playing stop. I don't know which one is, strictly speaking, better. Go with that one. I mean unexpected token else. I got rid of it. Line 97. There's no else. Oh, no, sorry. I'm just not clearing my... Yeah. I'm getting indignant at this thing. Okay, so let's try playing with a glider. This might be really fast. Oh no, that's great. It runs into the edge and becomes a block. That's great. If I click clear, nothing happens because I haven't written that yet. How do we clear the board? Yeah, so we could make a new board. What's another way? Yeah, how do we set everything to dead? We have a, sorry? Yeah, there is a, let's see. Yeah, there's an everything is alive rule. Right, so we can basically do this, right? We can say call tick and but tell it everything's gonna live. And actually,
You have to see it.
yeah, so let's copy that and say that present, future, and we'll pass in a rule that says everything is dead. Like, I don't care what the current state is or how many living neighbors it has, it's dead. What's that?
That's ES6, right?
This arrow function is ES6, yeah. We could also write this.
Yeah.
Also an option.
I like the first one.
Yeah, I really like the first one better too. Okay, so now we can run our glider and then we can clear. Great. Okay, and now I think we can use a similar strategy to do random, right?
Function sense.
Yeah.
Using math.random.
Yeah, exactly. And will that work? I think that might not work. That might just make everything live. Let's find out. Or yeah, we'll have to do something like saying math.random, is it less than 0.5? So that should give us, yeah, there we go. Cool.
What is the semicolon now? How
What's
does
that?
work? The semicolon?
Oh, we actually don't need these.
Oh.
You only need them if there's something before it that it can think, that it could think will run into it. It's like the one time when not using semicolons really can damage you. Because this can join an expression, right? If I had just x on this line or something, then JavaScript will interpret it as x of present future. It's a really confusing error to get.
So you're just saying when you're using a square bracket for a semicolon?
Yeah, when you start a line with a square bracket, or a backtick, or a open paren. Open paren is actually the biggest trip up that I've had. Great. So I think that's everything, and I think we can even make this a much bigger board, right? We could do like width of 100, height of 100. Oh, that's a really big board. Maybe that's too big. Maybe it's not too big. Let's find out. No, you can do it. It does seem to be weirdly stuttery, right? It does look that way, doesn't it? I don't understand why that could... Oh, there, it's doing it. It's doing it. Okay, so maybe that's a bit large for our game. How about like 64 by 64?
Yeah.
I also wonder, actually, wait, let's keep it at 100 by 100 and try... Remember how I said 4 of loops are not necessarily the fastest? So let's try and use the fastest loop we can. So let equals 0 while oh sorry, let I is table cells dot length. My computer is really starting to take off. It is a little faster. Someday they will optimize that more completely. It's interesting to me that it like really pauses during the scroll. Okay, and maybe there's other optimizations we could do. Honestly, if we really wanted to optimize this, we would probably draw it on a canvas. That would really help. And if we really wanted to make it faster, we could draw it on a WebGL canvas, where we could basically render the underlying board buffer directly. We could store it on the video card and teach the video card what a cell should look like and say, here are the cells, and then have all of the work happening not on the processor, but on the graphics processor, which is how really fast things happen. Okay, any other questions or anything you want to see or want me to talk about?
Just a comment.
Yeah.
We weren't sure how to like flip the board to even make a cell alive. So maybe we can read something.
It might not be explicitly clear.
And that like
Like our game was working, we just didn't, we had to literally click the cells.
Oh, really?
Yeah.
No. Wait, it's working?
Yeah.
That's awesome. Yay.
So that maybe could be more clear, or maybe we just didn't read it somewhere.
Yeah.
But we kind
The
of
reading was pretty long, so that might
Yeah, it might not be clear. We can definitely clarify that. Okay, cool. Great work. If you had or are very close to a working game, congratulations. Otherwise, you are probably closer than you think, and I encourage you to try it. And what do we have now? That's all for Game of Life. That's the last time you're going to be directly manipulating the DOM. That's not totally true. That's not true at all. This is the last time you're going to be having fun, though. So we have a retro now. Where shall we do our retro? In there? Is that better? We will see. In the flex room? What if we did it? We could do it in here. Okay, let's take a little break and.
Yeah.
It's like
Yeah.
Either way, we're just pushing it to the next place.
I guess the difference is not the stuff. So take a little break and then let's meet in there in, let's say, 5 minutes. Okay, let's see.